Hi students, today we are going to see the subject Thermal Engineering 1 in this unit 1 regarding air cycles. In this lesson 1 is Otto cycle or constant volume cycle. This cycle consists of 4 processes. 1 to 2 is isentropic compression, and 2 to 3 is constant volume heat addition, and 3 to 4 is isentropic expansion, and 4 to 1 is a constant volume heat rejection process. Let us see how to find the efficiency of Otto cycle. This is the ratio between work done and heat supplied. So this work done we can find by taking the difference between heat supplied and heat rejected. Therefore, efficiency of Otto cycle is equal to heat supplied minus heat rejected divided by heat supplied, and finally it is equal to 1 minus heat rejected by heat supplied. Let us take this as equation 1. In heat supplied, it is equal to mCv dt. So here Cv we have considered because heat addition takes place at constant volume, and dt is T3 minus T2 because during heat addition the maximum temperature is T3 and minimum temperature is T2. And heat rejected Qr is equal to mCv dt because heat rejection also takes place at constant volume, and dt is equal to T4 minus T1 because the maximum temperature is T4 and minimum temperature is T1 during heat rejection process. Now we are going to substitute the equations 2 and 3 in equation 1. We get efficiency of Otto cycle is equal to 1 minus mCv T4 minus T1 divided by mCv T3 minus T2. mCv gets cancelled, and finally we get the efficiency of Otto cycle as 1 minus T4 minus T1 by T3 minus T2. This equation is in terms of temperatures only. Now we are going to bring this equation in terms of compression ratio. What is compression ratio? It is a ratio between total cylinder volume and clearance volume. The total cylinder volume is a sum of clearance volume and stroke volume. So RC is equal to VC plus VS by VC. Now the total cylinder volume in PV diagram we show as V1. So the clearance volume plus stroke volume is equal to V1. V1 is also equal to V4, and the clearance volume is nothing but V2. V2 is also equal to V3. Now the ratio between V1 by V2 or V4 by V3 is nothing but a compression ratio. Now when we consider the process 1 to 2, the relationship between temperature and volume are T2 by T1 is equal to V1 by V2 power gamma minus 1, and V1 by V2 is nothing but RC, compression ratio. Therefore we get T2 is equal to T1 into RC power gamma minus 1. Let us take this as equation 5. Now when we consider the process 3 to 4, T3 by T4 is equal to V4 by V3 power gamma minus 1. This V4 by V3 is nothing but RC. Therefore we get T3 is equal to T4 into RC power gamma minus 1. Let us take this as equation 6. Now we are going to substitute equations 5 and 6 in equation 4. We get 1 minus T4 minus T1 by T4 into RC power gamma minus 1 minus T1 into RC power gamma minus 1. In the denominator, in both the terms, RC power gamma minus 1 is common. Let us take it outside commonly. So the remaining we get T4 minus T1 divided by T4 minus T1, which gets cancelled. Therefore finally we get efficiency of Otto cycle is equal to 1 minus 1 by RC power gamma minus 1. This expression clearly shows that the efficiency of Otto cycle depends on the compression ratio only. Thank you.